Students, now we learn how to fit a multiple linear regression model. So before fitting the multiple linear regression model, we should know the difference between the simple linear regression model and the multiple linear regression model. In the simple linear regression model, there is only one independent variable or predictor, uh, whereas in the multiple linear regression model, we can have more than one predictor in the model. So the data for fitting the multiple linear regression model I am using is the record 2.safe. It contains four variables here. So let us see what the details of the variables are. There the first variable is indicating the advertising budget. The second variable is record sales. Third variable is the number of plays this advertisement was played on the radio per week, and then fourth variable is the attractiveness of band. So here we have dependent variable as sales, whereas the other three are your independent variables. So potentially to determine the relation between the sales and the other independent variables, let us draw a matrix plot here. So for the matrix plot, you go to the graph and then scatter, and we select here matrix scatter because we have more than two variables. So to define all these variables, you should select these variables in this order I just explained. First, you should select your dependent variable, and then all the independent variables you can select at once. So all the variables are we have selected for this matrix plot, and once you click the OK button, you will see in the output. So that is our matrix plot. So we will be interested in the plots portion where your main dependent variable is correlating with the independent variables. So here it is. This is one of the plot where your main record variable is sales record variable is correlating with one of the independent variable, and possibly this variable is your budget for the advertisement. And then here we have a matrix plot of the record sales with the number of plays on the radio per week, and then in the last we have a matrix scatter plot where we can see the relation between the record sales and your attractiveness of band. So these three plots are our in our most interest because we can see here the what the relations are between our dependent variable and the one by one all independent variables. So here we can see that this relation is pretty strong, whereas this is relatively less strong as compared to this one. Whereas here, though there is a slight positive relation, but that is not that much strong. And now to fit the regression, multiple regression, you first should check the uh, normality of that variable, which is the dependent variable. So to check the normality, you should follow the slides or the video where I have explained how to test the normality of the data. And now we move to the multiple regression fitting. And for that, go to the analyze and then regression and then selecting the linear regression. So here we have the setup in this way. All the variables by default are on the left side of the window. You select your dependent variable here, and all these three independent variables are selected in the independent portion. And in the statistics, you should check here the estimates which are selected by default and the model fit selected as default, but you will yourself select this option, which is collinearity diagnostics and the Durbin-Watson statistics. And why we have selected all these two options, the detail and the interpretations are lying in your Word document, and I'll share with you uh, after a while. So continue over this window, and then Um, Here we have to select the method, and here we have few methods. The first method by default it is selected is entered, but we will select stepwise. So once you select the stepwise method, you should just click on OK button here. So in this way, that would be your output. Few of the tables are more important here, where the model summary is very important table, ANOVA is important table, and then coefficients. These are three important tables that I will discuss with you in a separate Word document. But let me explain first what these tables are about here. So in this table, you see this stepwise regression fitting. The procedure of fitting the model by using this method is, first of all, it selects only one independent variable in the model, which is explaining most of the variation in our dependent variable, which is sales. And here the detail is lying that in the first model, the procedure has selected the variable number of plays on the radio per week, because this variable is explaining most of the variation in your sales, so that's why it has selected this variable first. This value under the R pertaining to the model 1 is your correlation. It's a simple correlation because this is a simple regression model. Why it is so? Because it has selected only one independent variable. So the R square is your explain. It is explaining the variation that your independent variable is explaining in your independent variable. So you can say that 35.9% of the variation in your sales is explained by our independent variable, which is number of plays on the radio 1 per week. And similarly, for the second model, the procedure had selected two independent variables. The first variable is the same as it was selected in the first model, whereas the second variable is your advertising budget. Now, the reason of selecting this advertising budget in the second model is after the maximum variation explained by your first variable, that is the on priority, this variable is explaining the variation afterwards. So that's why it has selected the advertising budget. So now here you can see the correlation is 0.79. Now this correlation is called multiple correlation. Multiple correlation is the correlation between dependent variable with the combined effect of two independent variables. And now the R square is 62.9% of the variation in the sales is explained by these two independent variables. And similarly, for the third model, it has selected all these predictors here. You see here the details are lying, and all these three predictors are lying over here. And now the multiple correlation is 0.815, and that is the all combinedly these three predictors are correlating with your main dependent variable. That is the correlation of 0.815. And now these three independent variable combinedly are explaining 66.5% of the variation in your dependent variable. As you see here, these values in the adjusted R square and the R square, these are relatively very close to each other. Why it is so? The reason is because in each of the model, only the predictor used are the predictors which are significant. In case we have any predictor in the model that is not significant, in this case, these R square and adjusted R square values are quite away from each other. There can be larger differences between. But here you can see we have very small differences in between the adjusted R square and the R square. Here we have another Durbin-Watson statistics to see whether the error terms are independent in this model or not. So in case this Durbin-Watson statistic value is lying between 1.5 to 2.5, our model is safe from autocorrelation issue. So here it is 1.95, it is in between 1.5 and 2.5, so we are safe. And now the next model is testing the significance of the model. So each model has been tested here under the one-way analysis of variance. So the first model is significance is this p-value is less than 0.05, and same is the case with the second and the third. So all these three models are significant. So Now the question is whether the only three models are fitted when we apply the multiple regression model under the method of stepwise. The answer is no. It is depending upon the number of predictors, and furthermore it is dependent on how many predictors are playing a role as a significant. So that is all dependent upon the number of models this procedure will fit. It is possible that we may have more than three models in case we have more predictors, and depending upon the situation what is the significance of these predictors are. And then we have a table to discuss is the coefficients. So these are all the parameter estimated for the regression models, where you can see only two parameters are estimated because this is simple linear regression models. Here we have two parameters estimated because we have two predictors here, and in the last model we have three predictors, so that's why we have four parameters in total estimated. The first value, which is indicating the constant, that is the intercept, whereas the other values are indicating the regression coefficients. And now I take you to a Word document where all these tables that I have selected or discussed here. Another parameter or another characteristic we have here, that is VIF, variance inflation factor. So variance inflation factor is actually calculated to see whether there is a multicollinearity issue in the model. To understand what the multicollinearity issue is, sometimes your predictors are correlating with each other, and that is not considered as a good model in case there is such element in your model. So how you can detect whether the multicollinearity is there or not? You should watch the values under the VIF. In case any of the value here is greater than or equal to 10, it means that particular or the associated variable is correlating with any other predictor. So while removing such variable which is correlating with the other, you can get rid of such problem. But how you can detect is the VIF. You just go through the values of the VIF. In case these are greater than 10, uh, you can see that the multicollinearity can be there. But now in our case where we have fitted three models, in none of the models any value is increasing uh, or it is larger than 10. So all the values are less than 2 even. So there is no any multicollinearity issue in any of the model. And now let's discuss all these tables on a Word document. And here I have discussed all that. The portion I have taken from your matrix scatter plot, and the details of each the scatter plot is lying in the yellow highlighted box, so you go through it to understand the concept and make yourself clear about. And now the first model, that is indicating you the details of the model, all the details about the model and whatever the values we have to interpret, all these interpretations with the arrow keys to see their relation with the values. It is written over here. You just by giving a pause to this video, you can read all these informations. And now here we have the second table where you can see the significance of the model. So all these models are significant written over here. And then we have the last model to discuss, which is the equations related where the parameters are estimated. So this is the model where all these informations are lying. And now the last thing is that what these equations of the models are. So here we have the model 1. So this is the equation of the model 1. So since our dependent variable is the sales, so sales is your dependent variable, whereas the other parameters are lying over here, and these parameters have been selected from this portion of the first model. And similarly for the second and third, you can also choose the values according to the model. So here the variables are written as it is. So you can see here in the first model there is only one predictor, so that's why it is simple linear regression model. In the second model we have two predictors. One is the number of radio plays and the other is advertisement budget. And in the last model we have three predictors in use. And now how to use these models. I have chosen one of the data entry cell from that data, and here the entry numbers 18 has been selected for using these models. So in the 18th entry, the advertisement is 196.65, sales are 210, and airplay is 36, and attract is 8. So we estimate the sales by using all the models. So here you can see I have plugged in all the values in the models. So according to the model 1, the estimated sales are 226.677, and for the 2 it is 187.437, and the estimate for the model 3 is 200.002. And for the same all estimates, I've calculated the residual values here. And what the residuals are, I have explained it in the simple linear regression model videos. So that is the multiple linear regression model, and by going through all the procedure I explained, you can fit the multiple linear regression model. And for the practice of the multiple linear regression model, you can use the data uh, cars I just car underscore sales, so that you can select the data from the library. Here it is, you can practice it. So I'll give you an assignment related to this data so that you can fit a multiple linear regression model on this data, and that's all.